Hello everyone. Today we will talk about data representation. What does data representation means? It means using some techniques we will transform our data from one type, you can say from one format to another format. Second question comes into our mind is, why do we need this? Why do we need to transform our data from one format to another format? The answer is to simplify our data for the purpose of some arithmetic operations or some logical operations. What are they? The first operation that needs the data transformation is subtraction operation. Suppose we want to subtract two digits. Okay, so for that we have to put some digit, like I have to perform 110 from 101. Okay, but the problem is, how can we store negative sign, this sign? So for that we use multiple formats to feed our negative element in our machine. Okay, so what will happen, if we will perform some subtraction operation, like I have to perform a minus b, it will our data representation will convert it to a plus minus of b, and minus of b will be some value which we will represent using many type of data representations. Okay, now coming to the next point, what are some formats in which we can represent our data? So broadly we can divide these formats into two parts. First is based upon magnitude, second is based upon complement. Okay, based upon magnitude we have two types. First is signed magnitude, and second is what we generally use, that is unsigned magnitude. Okay, in complements we have two types. First is R's complement, and second is R minus 1's complement. Okay, R's complement is also called radix complement, and R minus 1 is also called diminished radix complement. So the first representation is signed magnitude representation. In this, basically the most significant bit, that is leftmost bit of our number, shows the sign of number. Okay, if it is 0, then it shows positive number. If it is 1, then it shows that it is negative number. So for example, let's suppose we have to show minus 9 using 5 bits. Okay, so in 4 bits there will be magnitude, and the fifth bit, the leftmost bit, will show the sign of our number, that is negative, means minus. Okay, so for example we have 5 blocks. Okay, 5 bits to represent. Now minus 9, it is binary. Okay, you have to do it in binary way. So first there is given 9 as magnitude. So magnitude of 9 is in binary, 9 is basically 1001 base 2. Okay, so it will be 1001, and MSB, that is our fifth bit from right to left, the leftmost bit will show that it is negative. So because it is minus sign, so we can say it will be 1. Okay, so minus and 9. In this way we show our sign and magnitude representation. Okay, suppose we have to show just 9. What we will do, we have to represent plus sign in MSB, so it will be 0 in that case. Okay, now consider we have to perform some arithmetic operation using this. For example, we have to subtract 7 minus 3. Okay, So for this, what is 7 in binary, by the way? That is 111 base 2, and 3 is 011 base 2. So if we have to perform this subtraction using sign and magnitude, in that basically what we will do, let's suppose we have to use 4 bits system. Okay, so fourth bit will be 0 in this case. Okay, because we are going to perform plus sign here, and there will be 0 because it is plus 3. Now what we have to do, 7 minus 3 will be 7 plus minus of 3. So 7 will be same as this, but minus 3 will be the sign and magnitude representation of minus 3. So first we have to write 7 will be 0 1 1 1. Okay, then 3 and minus 3. So magnitude of 3 is 0 1 1, and MSB will be minus sign, that is 1. Now if we will perform subtraction here, what we will do, we will differentiate it into two parts. First we have to perform subtraction on this, and here to decide the sign of the result, what we will do, we will take the sign of higher magnitude number and put it here. Okay, so here magnitude of 7 is greater than magnitude of 3. Okay, so 0 sign will be there in our result. Now we have to perform subtraction between these two. Okay, so 1 minus 1 0, 1 minus 1 0, and 1 minus 0 1. So plus and 1 0 0, that is plus of 4 base 10. Okay, and you all know 7 minus 3 is plus 4. Okay, so in this way we perform any subtraction using sign and magnitude representation. So now we have to talk about the range of this number system. Range in terms of number of bits we are storing the numbers. Okay, so suppose we have 2 bits to store numbers, then we have 2 bits. This will show the magnitude and the other will show sign. So what it will show, it may be 0, it may be 1. Okay, similarly we can have 4 possible outcomes: 0 0 0 1 1 0 1 1. Okay, what it will show, it will show 0, it will show plus 1, it will show the sign is minus and the magnitude is 0, means minus of 0, and it is minus of 1. Okay, so it is drawback because 0 and minus 0 are different here in this number system. Second thing is, we were telling about range. So the range for 2 bits is minus 1 to plus 1. Now suppose we have 3 bit system, then what will be the range? You can see from here 111 to 011, that will be plus of 3, minus of 3 to plus of 3. Okay, so in this way, if we will talk about n bit number system, then it will show the range of minus 2 to the power n minus 1 minus 1 to 2 to the power n minus 1 minus 1. Okay, where n is number of bits. Okay, just put the value. If we are putting 3 here, okay, just suppose we have 3 bit system like as previous. So the range will be minus of 2 to the power 3 minus 1 minus 1 to 2 to the power 3 minus 1 minus 1. Okay, what it will be? You can say 2 to the power 2, 4 minus 1, 3, minus of 3 to plus of 3, what we were obtaining here. Okay, so the range will be this. So now we will talk about r's and r minus 1's complement. So basically in r's complement we represent the number as r's complement of any number will be equal to r to the power n minus n, where n is number of bits in that number and capital is that number which we want to subtract. Okay, and r is basically radix or you can say base. Okay, so for example we have to take 10's complement of you can say 7. Okay, so 10's complement means base will be 10, it will be decimal number, and 7 is in decimal number. Okay, so the 10's complement of this will be 10 minus 7, because it is 1 bit number, that will be 3 base 10. Okay, let's suppose we have to take 2's complement. Okay, so 2's complement we are taking base 2. Okay, r is radix. Okay, so we are taking base 2, so numbers will be in form of 0 and 1 only. So suppose we have to take 2's complement of 1 1 0 0. Okay, it is base 2. So how will we take? First we will take let x is 2's complement, then x will be r to the power n minus n. What it will be? R to the power n will be basically r is 2, n is 1 2 3 4, 2 to the power 4 minus 1 1 0 0. But here 2 to the power 4 is in decimal form. We have to convert it into binary form first. So 16 minus 16 base 10 minus 1 1 0 0 base 2. Converting it into our binary system, it will give 1 0 0 0 base 2 minus 1 1 0 0 base 2. Okay, what will be the answer? Just calculate it. 1 0 0 0 0 0 minus 1 1 0 0. Okay, 0 0. So 0 minus 1 we will take a borrow. 1 0 minus 1 1 and 1 minus 1 0. Okay, so the answer will be 1 0 0. So it is our 2's complement of 1 1 0 0. Okay, so after that, what is r minus 1's complement? So r minus 1's complement is basically r to the power n minus 1 minus n. Or in other words, you can say r's complement will be r minus 1's complement plus 1. Okay, okay. Consider the previous example where we have given 1 1 0 0 base 2 and we have to calculate now 1's complement of this. Okay, so in 1's complement what we will do, we have to take r to the power n minus 1 minus n, or you can say r is here 2. Okay, r minus 1 is 1, then r is equal to 2. 2 to the power n, what is n? N is here 4 minus 1 minus n, n is 1 1 0 0. Okay, so what will be 2 to the power 4 minus 1? 1 0 0 0 minus 1 minus 1 1 0 0. What it will give us? It will give me 1 1 1 1 minus 1 1 0 0. Okay, so it will be 0 0 1 1 base 2. So it will be the 1's complement of 1 1 0 0. if we want to calculate 2's complement, just add 1. If we will add 1 here, what it will give? 1 1 0, 1 1 0 and 1 0. You can see from previous example, the 2's complement of 1 1 0 0 was 0 1 0 0, and hence we have proved this. Okay. Now we will talk about 1's and 2's complement. The one way to calculate 1's and 2's complement is that r and r minus 1. Okay. So from there we can say r is equal to 2 and then r minus 1 will be 1. But there are some other techniques through which we can calculate it easily. Okay. So for 1's complement we have to just flip the bits. Okay. Like we have to give 1 1 0 0. We are given base 2 and we have to convert it into its 1's complement. So 1's complement will be just flipping all the bits. Flip all the bits. Or you can say we have to individually apply NOT gate on each of the bit. Okay. So it will give 0 0 1 1 and it will be a 1's complement of 1 1 0 0 base 2. Okay. So from here you can see in our last example we have calculated is same we are getting here. Okay. And for 2's complement we have to just add 1 in here. Okay. 2's complement is basically 1's complement plus 1. Okay. So from here if we want to calculate 2's complement of same number, what we will do? 0 0 1 1 base 2 plus 1. Okay. It will give me 0 1 0 0 and you can verify it from our previous example. Okay. So in 1's complement we have to just flip our bits what we have given, and in 2's complement we have to just flipping all the bits and then add 1. Okay. Now when we know how to calculate 1's and 2's complement, we should know why are we calculating it. Okay. So in general I told you earlier that if you want to represent some negative number, then we use this type of representations. Okay. So how will we represent our negative number in this complement? Okay. So first let's consider we have to represent minus 9. Okay. So for minus 9 we have to first calculate plus 9. Okay. Then we have to just flip all the bits and we will get its 1's complement, and then we will add plus 1 and we will get 2's complement after. But the twist is the magnitude of 9 is 1 0 0 1. We will add 1 bit here for sign purpose. Now we have to flip all the bits. Okay. Why? Because if we say about range, what is the range of 1's complement number and 2's complement number, then the range of 1's complement number is same as our sign and magnitude numbers, minus 2 to the power n minus 1 to 2 to the power n minus 1 minus 1. Okay. Now look here, the magnitude of 9 can be calculated within 4 bits, but we have to first check that if 9 can be represented in 4 bits or not. Okay. So for 4 bits, 2 to the power n minus 1 minus 2 to the power 3 minus 1 to 2 to the power 3 minus 1. Okay. That will give me minus 7 to plus 7. Okay. Now we can see 9 does not come within this range, so we have to take at least one sign bit to represent it in 1's complement. Okay. So now coming to the question, we have given plus 9. Okay. Now we will flip all of its bits. Okay. So 1 0 1 1 0. So it is the 1's complement representation of minus 9. Okay. So it is basically minus 9 in 1's complement representation. Now if we talk about 2's complement, how we will calculate? Just add 1 in this and we will get 2's complement. 1 0 1 1 1 base 2. So it is minus 9 in 2's complement and it is 1's complement. Okay, it is 1's complement, it is 2's complement, right? Also 1's complement range is this and 2's complement range is minus 2 to the power n minus 1 to 2 to the power n minus 1 minus 1. Okay, so let's consider an example. Let's consider we have to perform 5 minus 7. Okay, using both the techniques, 1's complement or 2's complement. So first we will consider 1's complement. What we will do, if we have to perform using these two techniques, we have to first take the negative number and we have to convert it using 1's complement or 2's complement. Okay, in 1's complement we will take the negative number as the positive of 1's complement of positive number. Okay, so in this example 5 will be how much number of bits we want? We want at least 4 bits. Okay, because for 4 bits 1's complement range is from minus 7 to plus 7 and these two numbers fall within the range. So in 4 bits plus 5 is 0 1 0 1 and in plus numbers means positive numbers, the unsigned number and all the representations are same. So plus 5 will be this and we can write it as 5 plus minus of 7. Okay, right? So minus 7 will be 1's complement of plus 7. What is plus 7 in 4 digits? It will be this. So 1's complement will be 1 0 0 0. Now we will perform addition. 1 0 1 1. Okay, we have got a result, but it is not our final result. Why? There are two cases. If there is any n carry generated, means in MSB after performing the operation in MSB we get an carry over there, then we will add that carry in our result and we will get our final answer. But if it is not generated, then we have to take 1's complement of it and put minus and we will get our result. What I am saying it, minus of 1's complement of this will be our final result, minus of 0 0 1 0, and you can see it is minus of 2 base 10. 5 minus 7 will be minus of 2. Okay, for second case let's consider reverse of it. Just we have to perform 7 minus 5. So 7 will be 0 1 1 1 and minus of 5 will be 1's complement of 5, 0 1 0 1, and we have to take its 1's complement. So 1 0 1 0. Just add it. What we will get? 1 1 1 0 carry 1 1 1 0 carry 1 1 1 0 carry 1. Now n carry is generated. After this we got this carry. So this carry will be added in our result. Okay, we will remove it from here and we will add it into our result. What we will get? 1 1 0 1 0 0. So this is our final result. Okay, and you can see 7 minus 5 is plus 2. Okay, now we will do this same problem using 2's complement. If we will use 2's complement, we will take 2's complement of the number of which we want to subtract. So this will be same, and 5 will be 0 1 0 1. Okay, now minus 7 will be 2's complement of plus 7. What is plus 7? plus 7 is this. 2's complement of this will be 1 0 0 0. First we will flip all the bit, then we will add 1. What we will get? 1 0 0 1. So this will are 2's complement of 7. Okay, 1 0 0 1. Now we will add both of the number. 1 1 0 1 1 1. Okay, so in this you can see we are getting 1 1 1 0. Here will be two cases. First case is end carry is not generated, which you can see here. For that we will take 2's complement of it and we will just put minus sign before it. Okay, so it will be R dash. Our final result will be 2's complement of this. What will be that? 0 0 0 1 plus 1. Okay, or you can say 0 0 and put minus here, 1 0 minus base 2, and you can see that it will be minus of 2 base 10, and 5 minus 7 is minus 2. Now consider the second case. If we have to perform 7 minus 5, what we will do? That will be 7 plus minus of 5. So 7 will be 0 1 1 1 and 5 will be 2's complement of plus 5. So 2's complement of plus 5 will be 0 1 0 1 is plus 5. Then we will go to 1's complement, that is flipping the bits. Now we will add 1 and we will get 2's complement here. 1 1 0 1. Okay, 1 0 1 1 and we will add it. Okay, so 1 1 0 1 1 1 1 1 1 0 1 1 0, and you can see end carry is generated. We will put it here. Now what we will do in case of 2's complement? In case of 1's complement we were writing this in a result, but in 2's complement we will simply discard it, and the final result will be 0 0 1 0 base 2, or you can say it 2 base 10. Okay, so you can clearly see 7 minus 5 will be 2. Okay, so in this way we perform complements and operations using complements. Okay, so finally we can say that we had two type of representation techniques. First is based upon magnitude. There were two types. First was signed, second was unsigned. Unsigned is basically the numbers we represent in general terms, like there is no sign, and that can only represent plus number. So positive numbers are represented similarly in all the cases. But in case of negative numbers we have three types. One is of that magnitude type and two of the complement types. The two of complement types are first is R's complement and second is R minus 1's complement. But we are talking about binary system. In binary system, if we take radix as 2, then it will be converted as 1's and 2's complement. So in 1's complement, what we will do? We have just flipped the bits, like here 0 1 0 1, we flipped it into 1 0 1 0. It is 1's complement of plus 5, or you can say it minus 5. So the minus means negative number of the positive, means negative equivalent of the positive number will be 1's complement of that positive number. But in 2's complement we just add 1's complement with 1 and we get 2's complement. And now we will say that the 2's complement of the positive number is the negative equivalent of that number. Okay, and last we have seen some examples how we will calculate, how we will perform subtraction, and in sign magnitude we were representing the whole number, the magnitude of all the numbers, and the MSB was telling us what the sign of that number is. Okay, so in this way we can represent our number in all the types, like sign and magnitude, and r minus 1's complement, that is 1's and 2's complement. In unsigned numbers there are no any complexities. Just write the magnitude of number, that is unsigned representation. Like 5 we have to write, we can write it 101, and that is our unsigned magnitude representation. The drawback of unsigned is basically it cannot represent the sign of the number. Okay, it just says the magnitude of number. Okay, thank you.